The question is, let P be a point in a square ABCD. Join P to the corners of the square to make four triangles PAB, PBC, PCD and PDA. Let Q1, Q2, Q3 and Q4 be the respective centroids of these triangles. It is a fact that Q1, Q2, Q3, Q4 forms another square. Find the ratio of the areas of the smaller square to the larger square. Now look at the diagram. Here the bigger square is A, B, C and D. And P is a point within that square. P has been joined to A, P has been joined to B, P has been joined to C. Similarly, P has been joined to D. Now, Q1 is the centroid of the triangle APB. Similarly, Q2, Q3 and Q4 are the centroids of PBC, PCD and PDA respectively. We know from geometry that Q1, Q2, Q3, Q4 is a square. So we have to find out the ratio of the area of Q1, Q2, Q3, Q4 and A, B, C, D. Let the coordinates of point P be xy and let the point D be at the origin, that is 0, 0. And the sides DC and DA are along the x and y axis respectively. By doing this, we are not in any way constraining the problem without sacrificing generality. We are doing this. Let the sides of the square A, B, C, D be A. Then point D is at the origin, that is 0, 0. Therefore, point C will be A and 0. Point B will be A and A. Point C will be 0 and A. Now, these are the coordinates of the 4 points A, B, C and D, which are the vertices of the square. Let E, F, G and H be the midpoints of the sides AB, BC, CD and DA respectively of the square. Then the coordinates of point E are A by 2, A. Coordinates of point F is A, A by 2. Coordinates of point G will be A by 2, 0 and coordinates of point H will be 0, A by 2. Join PE, that is PE, PF, PG and PH. Now these lines PE, PF, PG and PH are the medians of the triangles APB, BPC, CPD and DPA respectively. The centroids of these four triangles are always located on the medians at a distance which divides the median in the ratio of 2/3 to 1/3. That is, if you call the centroids Q1, Q2, Q3 and Q4, then the distance of PQ1 will be 2/3 of PE. Similarly, PQ2 will be 2/3 of PF, PQ3 will be 2/3 of PG and PQ4 will be 2/3 of PH. Let us now find the coordinates of Q1, Q2, Q3 and Q4 from this. We already know the coordinates of P is xy and also we know the coordinates of E, F, G and H, which are the midpoints of the sides. We have also written down the values of these coordinates in the diagram. From coordinate geometry, we know the formula for internal division of a line, and that formula is the coordinates of a point that divides the line segment joining points x1, y1 and x2, y2 internally in the ratio of m:n are given by x is equal to mx2 plus nx1 whole divided by m plus n, and the y coordinate is my2 plus ny1 whole divided by m plus n. Look at the diagram where 1 endpoint is at x2, y2, another endpoint is at x1, y1, and the point in the middle P is dividing the distance between A and B in the ratio of m and n. Now, let us apply this formula with respect to our particular case. For point Q4, the diagram is written here. One end, that is H, is at 0, a by 2. The other extreme point P, the coordinates are x and y, and in between the point Q4 is there, which divides the line HP in the ratio of 1:2. Okay. With respect to the formula, in this case, m is equal to 1, n is equal to 2, x1 is 0, y1 is a by 2, x2 and y2 are x and y. Now, putting these values for the x coordinate of Q4 with the formula mx2 plus nx1 divided by m plus n, we get 1 multiplied by x plus 2 multiplied by 0 whole divided by 2 plus 1, and that is equal to x by 3. This is the x coordinate of the point Q4. Similarly, the y coordinate of point Q4, the formula is my2 plus ny1 divided by m plus n, and in this case y2 is equal to y, y1 is equal to a by 2. Therefore, we get 1 multiplied by y plus 2 multiplied by a by 2 whole divided by 2 plus 1, and therefore the y coordinate becomes y plus a divided by 3. So the x and y coordinates of point Q4 we have found out as x by 3 and y plus a by 3. Similarly, for point Q, the diagram is given here. The point P is at xy, point G is at a by 2 and 0, point Q is in between, and point Q divides the line P and G in the ratio of 2:1. So, in this particular diagram, m is equal to 1, n is equal to 2, x1 is equal to a by 2, y1 is equal to 0, x2 is equal to x, and y2 is equal to y. Therefore, the x coordinate of Q3 using the formula mx2 plus nx1 by m plus n is equal to 1 multiplied by x plus 2 multiplied by a by 2 whole divided by 2 plus 1, and that is equal to x plus a divided by 3. And the y coordinate of Q3 is, again using this formula, we get 1 multiplied by y plus 2 multiplied by 0 whole divided by 2 plus 1, and that is equal to y by 3. So we have found out the x and y coordinates of point Q3, which are x plus a by 3 and y by 3 respectively. Therefore, the distance Q3 Q4 is equal to square root of x plus a by 3 minus x whole squared plus y by 3 minus y plus a by 3 whole squared, that is equal to square root of a square by 9 plus a square by 9, that is equal to square root of 2 multiplied by a whole divided by 3. And this is the side of the square Q1, Q2, Q3, Q4. Therefore, area of the square Q1, Q2, Q3, Q4 will be square of the sides, and that will be equal to 2a square by 9. Similarly, area of the square ABCD with side A is equal to a squared. Therefore, ratio of the areas of Q1, Q2, Q3, Q4 to that of the square ABCD is 1 divided by other, and that is equal to 2 by 9. So 2 by 9 is the answer.